I'd like to welcome everyone to our presentation today on warmth. The topic is a third in our series of presentations with the Canadian Apparel Federation and Heat MX. In about 1 minute, I'll turn the floor over to Sei Chang, who will do the presentation. In the interim, let me just do a quick couple pieces of housekeeping items. My name is Bob Kirk with the Canadian Apparel Federation, and we're the host for today's webinar. For those that are joining us for multiple sessions, I think you'll have heard this drill, but for others, we have a quick couple pieces of housekeeping that I'd like to just mention. So first of all, the session will be recorded and it will be available to you within 24 hours. If you wish to have the slides themselves or a PDF of the slides, you can contact Sai and he can provide them to you. So the session will run for about an hour. If at any point during the session you have a question, you can ask a question by clicking on the question icon in your control panel, which is usually in the top right-hand side of your page. So if you do have questions, you should ask them. You can ask them during the session or at the end. And if for any reason we run the full hour and we can't get to the sessions, we will attempt to forward those questions to Sei, and he can contact you directly. And if they are of broad interest, if they are likely to be of interest to many companies, we'll try to circulate those to all firms that are on the line. So the bottom line is, for those just joining us, that the session will be recorded. The recording will be sent to you. If during the session you have questions, you should ask them. And if at the end of the session you still have questions, you should also ask them. So the bottom line is, this is supposed to be a session for the attendees. It's for you to learn what you need to learn about this product. And I think we have no better presenter than we could find in Sei. So the bottom line is we are ready to go. At this point, I will ask if everyone's on the line. Sei, can you hear me?
Yes, I can. Thank you, Bob, for the intro. Hello, everyone. I hope everyone is doing well in this second wave of pandemic in many regions. My special thanks to the folks who are coming back from any of our previous webinars from part 1 to part 3. And I'd like to also welcome the newcomers. I hope you will be learning the things that you have not encountered before in the industry. So today we're going to focus on the thermal insulation for footwear and gloves. And today we put together 5 different segments. And for those who are coming back from any of our previous webinars, please bear with me because there are new folks who are joining in for the first time. So briefly about HINMAX and myself, and then virtual program. And then the second part, we're going to look at the important criteria for footwear and glove. If you compare other items that use thermal insulation technologies, for example, apparel, I mean clothing like jackets and pants, or the blankets or sleeping bags and whatnot, footwear and gloves are built quite differently. So we have a different set of criteria for footwear and gloves. So we'll be focusing on those specifics. And then in the third section, we'll be looking at the properties, performance features, and metrics. We'll talk a lot about nonwoven technologies because these are most widely used thermal insulation material in the industry. But also, I know that there are a lot of other technologies out there, piles or felt and foam. We'll briefly cover those as well. And then we're going to look at the base material qualities in various performance aspects, and then temperature ratings. And then number 4, we're going to look at do's and don'ts. And so do's in terms of the target applications, and coverages and things like that. And also, some factories are making critical errors in producing these types of products. So this would be quite important for us to review together, and then Q&A will be finishing. So by the end of this presentation, I hope that you understand what are really important factors for you to consider for thermal insulation material for footwear and gloves, and then how heat max technologies can address the areas that are often not um, covered by other insulation technologies out there, and then do's and don'ts in specifications of manufacturing. And so this last part, the do's and don'ts, this is applicable for um, regardless of what kind of thermal insulation material you use. And even if you decide to stay status quo, making no improvements and no changes, but you still might want to take a look at the practices or the manufacturing processes of your factories that produce the products, because there could be some critical issues there. So I'll be addressing those. So briefly, Heatmax is a company based in Montreal, Canada, and we offer 6 different product categories. And thanks to the breakthrough innovations in terms of the performance and environment, we have been recognized by ISPO Top of Innovation Award, including 2 patent pending technologies, and we also have a lot of IPs in our product properties and how we contribute to the environment. And this is why we were recognized by the ISPO for the Innovation Award. And once again, we're headquartered in Montreal, and we have regional offices in China and Korea, and in particular in China we do manufacturing, and we ship all over the world for our customers. And briefly about myself, I studied textile engineering, and I had experiences in R&D, sales, marketing, etc. Most recently, I was the transnational sales account manager for 3M Tinslate and Scotchlite, and I created all of the products and technologies under Hinmax brand, and I also invented the proprietary vision in motion technology. So when I send out, when you get the recordings and the files from Bob, you'll see my LinkedIn profile and contact information there, so you can contact me anytime. As we are not able to meet with the suppliers or customers, or we're not able to attend trade shows because of the COVID-19. There has been a lot of limitations in the industry in terms of getting to know newer technologies or important information that are necessary to be learned in the industry. So Hitmex has been working hard to convert our entire operation to deal with COVID-19 more effectively. That includes the overhauling our website and things like that. And as a part of that assistance program, we offer a series of webinars. And what we are doing today is one of them, but also we have other programs that can benefit the industry segments like apparel, footwear, glove, home textiles, sleeping bags, and food bags. Basically, wherever you need to use thermal insulation, you can take advantage of these. And the target audience, if you are related to the product specs or productions, sourcing, designs, you can take advantage of this. So we started this campaign on October 1st with, we kicked it off with the Canadian Apparel Federation, thanks to Bob's effort. And so we're going to continue this on weekly or bi-weekly basis until April 30th. And so far it's been going very, very well. And it's been very well received in big part because thermal insulation is a really important part of our daily lives or our businesses. If you look at the cost perspective, for example, if you want to buy a piece of shirt versus a piece of winter coat, there is a huge price difference in consumers' perspective. And also in our business, it's the same thing. Cost structure is much higher. And so it's such an important part of our businesses and daily lives for consumers' perspective, but it's um, it's not taught in the school, in most of the schools. In fact, I am a textile engineer, but when I went to school, I was not taught for these important subjects. And it's really hard to get important information in an objective way. Since we started this webinar series, the feedback that I have been getting is that it was quite helpful for them to understand the important areas for them to consider. So this is a part of the program. So we started, as I said earlier, on October 1st, and today we're doing the fourth, um, the fourth webinar. Then the next one is scheduled on the November 5th. I'll be announcing those in more details on our website. And then we also offer brand company specific or college webinars. So basically, if you have questions that you don't want to talk about because it's specific to your designs or a brand, then you don't want to raise questions during this open forum. We can actually organize a separate webinar to talk about your company's specific needs and the questions, and then we can set the time based on the convenient time of each organization who's interested in this. So let's get into the real details of the important criteria for the um, footwear and gloves. So obviously, we're talking about the winter goods. It has to be warm. So that's a check for both gloves and footwear. Now, volume is also an important part for us to consider. So when I say volume, I'm saying something like this. So on the left-hand side, you see the work gloves, and on the right-hand side, you see the ski gloves. So ski gloves, so you just need to hold the ski poles, whereas with work gloves, you might actually have to pick up small objects. So volume plays an important part here because if it's too voluminous, it's not going to work that well for the work gloves. So when it comes to the footwear, you see the footwear on the right, you see these quilted areas where you see higher volume and lower volumes. And so for this type of application, volume is more important. But here for the left-hand side, it's more plain. So it is one of those criteria that we actually have to take a look before you decide what kind of material you use for these areas. So let me get rid of this. And then sweat factor. Now, I covered this last week quite extensively because it's an important part of how we lose our heat. So most insulation material out there, they address the conduction or radiation. Sorry, I'm not quite familiar with this mouse operation here. But evaporation, it's often overlooked, but it's such an essential part of the performance of our products. So I'll be presenting some more details about that later on. So let me get rid of this. And so this is the body map where it shows the density of sweat glands. So basically what you see here is the number on the palm of the hand that says 310. So the density of the sweat glands in the palm of the hand is the highest in your body. And the second highest is the sole of the foot. So if you compare that with the forehead, for example, it's more than double. And the neck and the back, it's more than six times. So what it tells you is that taking care of the sweat is very, very important for glove and footwear. So this is what we're going to look at the later part of this presentation. Once again. Okay, and then climate resistance, of course, when the temperature changes, it still has to give you the warmth, but it's not only the temperature, but the wind and the moisture change and things like that also have to be considered. So glove and footwear, same thing. These are check marks. And the dexterity part, this is more for the gloves, especially when it's work gloves. This is a very important part that we have to take care of. And hand feel, some insulation material or the thermal insulation material gives you slippery feel, and that can be a bad thing for work gloves, for example. So this is another thing that we have to look at for, especially for gloves. So material types and application examples. So I'll give you a quick rundown of what kind of thermal insulation materials are out there and what they're made of and how they're usually used. So when you look at the non-woven, sorry, it takes a little bit of time for me to switch between the pen and eraser. So when you look at the non-woven, there are two types of materials. One is carded and the other is melt blown. I'm not going to get into the details of these materials because it will bore you. But how you recognize is, let's say these two are the same weight, but the carded materials are usually much thicker than the melt blown. That's because the way it is made. And carded materials, because of their volume, they're more often used for ski gloves than the work gloves, vice versa. And if you look at the footwear examples, the carded material would be used in these areas, whereas the melt blown would be used in these areas. So there are different shapes and forms and the different purposes that are used. And when it comes to raw material, carded material are synthetic or natural, both can be used. And only the natural material, you can only card it, not melt blown. But for the melt blown part, it has to be only synthetic. So that's the difference. And the warmth, initial warmth, because those ones who joined in for the webinar number 1 on October 5th, we talked a lot about how thermal insulation works and the quantity of dry air contained in the insulation material plays a big part. Now, because it has a higher volume for the same weight, the initial thermal efficiency or warmth, the carded material has higher warmth than the melt blown. However, it is not resistant to compression. So when you compress it, all the air pockets, I shouldn't say all, a lot of air pockets will be escaping, and you end up losing a lot of thermal efficiency warmth. So you end up having a higher thermal efficiency with the melt blown in certain type of applications. And the gloves and footwear are the typical two examples where a lot of compression is given during the manufacturing process. That's why it is quite different from other apparel items or home textiles and things like that. And hand feel, when it comes to, I'm not going to talk too much about the natural fibers because it's rarely used in the thermal insulation material for gloves and footwear, and there is an obvious reason for that because with the sweat it gets wet, and then it can create the smell and things like that. So for various reasons, it's mostly synthetic fibers that are used for gloves and the gloves and footwear. And then in the carded material section, um, synthetic fibers gives slippery feel. Now, some other descriptions used in apparel and other parts of the industry, they say they use terms like silky and luxurious hand feel. Well, it's same word, same same kind of description. It's slippery, basically. That's what it is, because of the treatment on the polyester fibers and things like that. So anyway, this slippery feel can be bad for the gloves and footwear, especially gloves. And when it comes to melt blown, it's not slippery. And typical applications include footwear. For carded, it's on the shaft area. It's rarely used on the sole area, like the melt blown. And when it comes to gloves, a ski glove versus work glove, we mentioned earlier. One thing that I will mention is that on the bottom, the footnote here, needle punched products are out there. These are a carded material, but they were made to try to mimic the behavior of melt blown. And so it is in between. It's carded, but it's in terms of the thickness and the where it's applied and things like that, it is closer to the melt blown. I just wanted to cover that. Now, when it comes to non-woven technologies, why are they used most often as a thermal insulation material in comparison with other types of material like foam, pile, or felt? Now, I think this graph shows it clearly. So what we did was we did the thermal efficiency. So claw divided by weight, and it's in the example of footwear. And you can so we did the analysis of that. Now, before I explain the values here, I just want to put it out there because there is a competitive brand. I think I got it from the competitive brands literature. So basically what they did was they tried to illustrate how efficient thermally of their material is by showing the relative warmth, claw per thickness. Now, I felt a little strange of doing this because thickness, as I said, in case of glove and footwear, there is a lot of compression involved. So when you start with the thickness, let's say hypothetically 1 centimeter of the material, you end up with losing half of it, or even more in some cases. So by comparing if you look at the foam, felt, and pile, it gets less compressed than the non-woven type of insulation material. So comparing the warmth based on the thickness, I didn't think it was the right approach. So what we did here in our analysis, we did the thermal efficiency claw divided by weight. Now we pay everything by weight, don't we? So even if you buy felt, you say you pay a certain amount of money per yardage, basically, which is calculated based on the weight. And so everything is done by weight. So I think that's more objective. So if you look at these 3 types of regular, I would say not non-woven material. I hope you understand this. And these are either fabrics or plastic technology. So if you look at the thermal efficiency, you will see that it's lower than the competitive brand here. The competitive brand, this is a brand that is most recognized in the industry as the footwear insulation material. Before the Hinmax came out, they were considered as the most efficient thermally in the market. But as you can see, our Hinmax is 2 to 3 times higher in terms of thermal efficiency. I'll give you a little better rundown of this. Now, I apologize for the folks who attended any of our previous webinars, but I think this is really important for any new listeners to understand. So I just want to quickly explain how the CLO or TOG is calculated, because we need to use this terminology quite often in the following slides. So basically, it measures the thermal capacity, meaning how much heat it can contain. So let's say you have a sweater and you cut the back of the sweater, and then you put it on the heat plate, and then you start raising the heat, and you measure the temperature of the heat plate and the temperature of the air using a temperature sensor, and the difference between T1 and T2, meaning how much heat is contained inside by measuring the T2, is the thermal efficiency or the warmth value of that particular fabric. Now, this heat plate can be shaped into a foot. So we call that thermal foot or thermal hand or thermal mannequin for an entire body of a person. And then measurement units are kilo for apparel and the TOG for thermal home textiles, or R value. So your house, if your house is efficiently insulated, then you can save a lot of heating bills or cooling bills in the winter and summer. So that gives you an R value. Now, let's look at the material aspect of it. Now, this is something that I emphasized quite a lot in the webinar number 1 and webinar number 2 as well. When we focus on the thermal efficiency or CLO warmth of the raw material, when it comes to apparel, it does not relate directly to the real life warmth because of the stitching and how this area, thicker area, has a lot of air pockets, whereas this stitched area has a lot of not a lot of air pockets. So it just gives you a real small part of the whole story, if you will, of the real performance of the jackets. But in case of footwear and glove, it's quite different in that perspective, because the warmth of the raw material, it often closely relate to the performance of the finished product in case of the footwear and glove, because we don't do a lot of stitching. Here we have some examples of stitching, but I have never seen any footwear application that it is left like the apparel, the example of an apparel like this. It always has a liner inside that evens out the heat distribution a lot more than the apparel. So stitching in this case is not making a huge difference in terms of the thermal efficiency or warmth between stitched area and not stitched areas. So that's why the high quality of raw material quite closely correlate to the performance of the finished material in footwear and gloves. But there are other things that we have to consider. So one example is abrasion resistance. And so I'll give you an example with a video after this slide. But we also have to consider protection against precipitation, sweat extraction, protection against wind. Now, these are things that you don't normally consider in thermal insulation. But Hinmax offers the technology solutions that will give you a lot of protection against these issues, and it will only help you enhance the performance of your footwear and gloves, um, regardless of what kind of other technologies that you use to add the additional functionalities. So I'll explain those to you a little bit later. Now, abrasion resistance. So I'll show you a little video here. So you can find, by the way, this video on YouTube under Himax channel. So this here, the circle part that I'm using my mouse with, this is a normal surface structure, but it gets so easily disturbed upon abrasion. So I have seen this quite often in my visits to factories in Asia, that there are some workers trying to remove the residues of the from the thermal insulation material on the furs and other parts of the upper. So this is because thermal insulation material, it easily disintegrates, and you can see this actually more often than you would like to see, because the manufacturing processes are not that gentle when it comes to dealing with these materials. Of course, there are factories that do better jobs than others, but once again, this is something that you can easily see in manufacturing factories. So Hinmax material, we actually put protection against this type of abrasive force. So even if there is a strong abrasive force given to the surface, it will still perform. So that is what is important. So when it comes to the warmth, this is a glove example for temperature rating. And for all our competitive analysis, please note that we use the same models, same ingredients in the whole constructions. And the only difference between the two tested samples is one with the Hinmax, the other with a competitive product. And in case of the competitive brand, I'm not going to mention a specific brand, but we use most typical, most widely known, or most widely considered as the top quality in the market. So if you look at this glove temperature rating example, on one glove we used Hinmax 150 GSM. This is a carded material. And the other one is a brand A. It's a top brand and top quality of that brand, 200 GSM. You can see that the temperature rating we registered better. So it has a lower temperature resistance, a higher temperature resistance with a lower quantity, meaning that we use a 25% less weight to achieve higher grade. That's coming because of the base material has superior quality compared to the other brand. So if you look at each gram weight here, you will see the claw values are much higher with Hinmax than the competitive brand. By the way, I have never mentioned this, but someone asked, it sounds really good, but Himex materials sounds really expensive, but it is not. Uh, in fact, it is either comparable or you can save the cost, because there are many factors involved. And a lot of my customers are actually saving a lot of money by converting to Heatmax. yet get a better performance. Now, when it comes to the footwear example in terms of the temperature reading, so we use the 200 GSM of competitive brand versus 200 GSM of Hinmax, and the temperature difference is minus 40 degrees Celsius or degree Fahrenheit versus minus 50 degrees Celsius or minus 58 degree Fahrenheit. Now this minus 10 degree difference, it's huge. It requires a lot of energy to reach that level of difference. So this just shows you how superior the base quality of our Hinmax material is. So if you look at the base material flow value itself at the same gram weight, it's either 3 times or 4 times higher in terms of um, the thermal efficiency or flow value. Now, you might say, well, then Hinmax has a 4 times higher thermal efficiency, or if you compare 200 GSM here and 200 GSM here with Hinmax, it's almost 50% higher than the competitive brand, but you still have the same temperature rating when you compare 200 GSM and 100 GSM of Hinmax. That's because of the compression factor. So what's important here is that Hinmax can accomplish the same temperature rating, minus 40 degrees Celsius or Fahrenheit, with half of the weight. So that's what's important. And this has been confirmed through many brands, my customers doing their own analysis and offered these types of analysis results. So obviously, when you can achieve the same level of performance with half the weight, you can save a lot of cost, because our insulation material, so some customers in Canada, they do temperature rating and they put the tags on the footwear saying minus 40 degrees Celsius, minus 50 degrees Celsius ratings, and they had to use 200 GSM, for example, before to get the minus 40 degrees Celsius rating. But now they can do it with our Hinmax 100 GSM, and they can cut the cost of the insulation material by half, basically. That's a lot of money. It's hundreds of thousands of dollars for a certain level of a brand. And also, you can produce a lighter material, lighter product, and that is also performance related, and people will have a better satisfaction. And the environment, if you can use only half of the material that other competitors use, obviously it's a lot more beneficial for the environment. Now, when I was promoting all these superior performances of Hinmax to my customers, I got a somewhat unexpected feedback, which was the the sales folks of some brand companies, they are accustomed to seeing the weight of insulation material as a quality indicator. For example, let's say there is a T brand, and in their labels they say 200 GSM, 400 GSM. So the sales folks were concerned that we don't indicate, or we actually indicate lower gram weight. Now, after that feedback, I actually came up with an analogy here. So basically, what you see two vehicles here, old vehicles and the new vehicle. Old vehicle, you have to have a huge fuel tank because fuel efficiency is very low. But with the new vehicle, you don't have to have such a huge fuel tank in order to cover the same distance. That's because fuel efficiency is much lower. So if you look at it in our thermal insulation perspective, you can get 200, a certain level of temperature ratings with 200 GSM of competitive brand versus 100 GSM of Hinmax, and 400 versus 200. So if you say, well, 200 GSM is really important, that's as if you're saying that you should buy this old vehicle because it has a large fuel tank. So I think the industry needs to update our approach to the consumers, because in the automobile industry, we actually put a lot of information out there to explain why this particular vehicle is good for the consumers. Now, not only the fuel efficiency in thermal insulation perspective of HINMAX is much, much better, but we also offer a lot of additional technology features. And I'll cover some of those. And I want to mention that we actually have breakthrough technologies that help the environment considerably. Um, so in this section, I'll be briefly talking about the protection against precipitation and sweat extractions. So we talked a lot from the last presentation that the industry has been focusing so much on the rain and snow, but this microclimate between the body skin and the product that we use is such an important factor. And when the humidity increases, the thermal conductivity increases quite a bit. So it's important to keep this area microclimate dry, but um, it is often not the case because it's not designed often in this manner. So industry is often talk about the waterproof level, and then also moisture vapor transmission rate and the breathability. Now there is a loophole. If the MVTR or breathability is measured under the natural evaporation state versus pressurized moisture escape from our body, like the sweat rate that you see here. So when we move around a little bit, our body generates the sweat at a much accelerated rate than the natural evaporation. And so this is an example. So we saw this body map earlier. Palm and the sole of the foot, it creates such a higher rate of sweat. In fact, if you look at the sweat rate here, it's approximately 1 liter per hour in fast walking. But this is the average of the body. If you actually look at these figures, this is actually 2 times than the average of the whole body. So this would be easily 2 liter per hour for the palm and the sole of the foot area. So this is why it's so important to take care of this area. Now HIMMAX offers dry cave technology, which actually, sorry, I'll put up another video. So in this demo, we put 2 cups of water. We poured hot water, and then we'll cover on one side waterproof and breathable fabric, and the other side we'll put the HINMAX product. So you'll see what happens after a few minutes. So we check the surface structure. You'll see a lot of condensations on the surface of waterproof and breathable fabric, and on this side it's very clean. By the way, when I provide you with the recordings, you will see all these HINMAX links. You can check it out yourself. That's because we actually have a very innovative process called adsorption, and it transports water molecules when it's the smallest size into the exterior. So it works very well with regular waterproof and breathable fabrics, because the way the waterproof and breathable fabrics work is that they have small holes that are much smaller than the water droplet, but it's larger than the vapor. So when you can transport water in small molecular size like our HINMAX technology does, it goes through the small holes much easier because of the technology. And in addition to these, we offer a very high level of water resistance and windproofness. So I'll quickly provide an overview of that. So we put the material in the cylinder like this, and then we'll pour water on top of it. And then we put a very weak amount of air on the bottom of this so that you can see the air is coming through, but the water is not coming down. And now you can, I can put this in my office and leave it like this for weeks, and they still will just water. And in addition, we don't use a very strong air coming from the bottom, because that in itself can boost the um, the um, the resistance of water. And another one, sorry, I should have done this before. Uh, Windproofness. So we use a very strong wind blower to Hinmax material. Now, before we did that, we measured the speed of the wind. It was close to 100 kilometer per hour. And we use the medium weight of our insulation material. You see how strong the wind is, given the shape of the fabric, but it blocks, like the fan is not turning at all, so it blocks the wind perfectly. So that's the type of exceptional performances that we offer in addition to the warmth. So it gives you a boost of the products that you are building. And because of that, we are able to offer a comprehensive temperature rating program for everything that you can think of. In fact, I've been working with a military program where they are asking for minus 50 degrees Celsius rating for high altitude. And I went back to them and I said, look, you actually need minus 75 degrees Celsius if you factor in the wind chill and everything else. So we're working based on that target. So it's a very comprehensive program. And the do's and don'ts, I'll try to be really quick. Obviously, if you think about it, your own experiences, the most sensitive part of your body when you feel cold is the fingertips and the toes. So in order to protect those areas properly, we have to actually do a proper coverage. I know a lot of footwear companies, they just stitch along the sole line here, but the best way is to wrap it around the edge area and then goes slightly under so that it covers a part of the foot. And that would be a better way. The best way is that you cover it in the entire sole area with thermal insulation, especially big Hinmax, because we offer such a good functionalities for sweat removal and other functionalities as well. When it comes to the, oops, sorry. When it comes to the gloves, I often see gloves with fourchette area not protected with insulation material. This is very important, as much as the palm and back area, the side area of the fourchette area is really important part. And the coverage, in addition to the coverage, we have to think about the target environments and the material specs. So, for example, the activity level and sweat factor, this is very important. So if you're building gloves for refrigerator workers versus the workers out in the field and do a lot of activities, then the specs that you incorporate might have to be a little bit different. And the wind factor is another important part to consider. Dexterity and warmth. So when you look at the carded and melt blown, there are different properties. So it might actually be a good idea to look at different parts of your hand and use different parts of the technology. And of course, it will take a little more things to take care of in manufacturing, but in terms of the performance, it can actually be a very good performance. Now, this is very important. So regardless of what kind of material you use, when it comes to thermal insulation, this is something that you have to look at. And because I have seen so many factories where their manufacturing processes and practices wipe out entirely the reason why you use expensive material to put the thermal value in there. Now, the most important part is the heat. When you apply excessive heat, that will either remove the air pockets that are there to provide the warmth or destroy the fiber structures altogether. Now, I've seen this example with hot melt bonding. Now, some factories, they glue thermal insulation with lining or fabric or lining or the and exterior shells so that they can cut it all once and then stitch it at once. But this is not a good process. The stitching is necessary, and the hot melt bonding in the stitch the joint areas, it can be done. But the hot melt bonding, usually temperature goes above the melting temperature or softening point of synthetic fibers. So if you do this improperly, you will melt away the fibers. Heated roll press is same thing. I've seen the heated roll so high of a temperature that it removes basically all the pockets, air pockets, and destroy the fiber structure. Vulcanization. Now this will destroy um, the uh, the fiber structure in most cases because temperature is so high. So if it's a vulcanized product, you might want to try to put warmth in different ways. Curing is mostly not a problem because I haven't seen the curing temperature that high, but you never know. Anything can happen in the factory setting, so you might want to check. Lastly, we offer so many different functionalities at Hinmax, and this is why we are recognized as a type of innovator in the industry in all our product categories. If you have any questions, you can address those to me. In finishing this presentation, as I mentioned at the beginning, Hinmax converted all our operations um, in order to navigate through the COVID-19 situation. And if you look at our website, we built the website based on the application specific content. So if you're interested in footwear, you don't have to go through the entire website to get the relevant information. All the information necessary for the footwear is in one place in our website. And I think it's for the first time in the industry, we offer 3D model-based video content so that it's easy for you to understand. And you can find also a wide range of technical data, and also upcoming notifications, webinar notifications are posted in our website. And hopefully in the next coming webinars, you will be able to join. So that's the last part of my presentation. Bob?
Thank you very much. So I think we covered a lot of ground there. I'll ask the people that are attending if they have questions to submit them. We have, a few minutes left at the end, and just for the people that join midway, before people start asking me, the webinar will be recorded and distributed. And secondly, we'll include a link to each of the two other presentations that Max has done with CAF. The sort of first, the second a little more specific, and of course this has been much more focused on specific applications. Now, in terms of the ones that are coming up, I think maybe you go back up one slide. It has a few that are listed there, but I think to be fair that you're going to be doing quite a lot between now, I believe in April. I don't know how much more you can talk about them now, but one way or the other, the best way for people to find out about those sessions is to email you.
Yes, in fact, Bob, thank you very much for addressing it. Now, as I mentioned earlier in the presentation, there is a big thirst, I find, in the industry to try to learn more about thermal insulation technologies. In fact, here in Max, we've done seminars and webinars in different countries and different times. Uh, Attendance has been fantastic. And that I think speaks volumes about the lack of information out there in this important segment of the textile industry. And that's why we see very good responses. So we have a lot of subjects that we can talk about. And not only thermal insulations, we have to look at it in terms of the entire product because thermal insulation is not a standalone component of the finished goods and it interact with each other. So there is a lot of subjects that we can talk about and we'll continue to offer hopefully helpful subjects to the audience. Thank
Uh,
you, Bob.
Very good. Yeah. And we got a question, and this is one of the things that sort of occasionally motivates me. There was a question about whether um, sort of national standards around footwear for thermal insulation. And the question was whether HeatMX would be willing to work to develop those standards. And I guess my question for you is, are there national standards in Canada or elsewhere or through the ASTM or whatever that are sound in terms of thermal insulation?
That is a great question. In fact, I should have mentioned this earlier when I was talking about the claw. Now, and the temperature reading. There are some laboratories in Canada as well as other parts of the world, and they give you a temperature rating based on the certain set of standards. Now, I am aware that there are some thermal mannequin-based ISO standard, which is obviously internationally recognized. I don't know if the temperature rating of footwear is recognized by one body or multiple authorized bodies. Last time I checked, it was individual effort by separate labs. So in fact, I had an occasion where we submitted two identical pairs of shoes to two different labs, and we got on one occasion we got minus 50 degrees Celsius rating, and the other one we got minus 20 degrees Celsius. Obviously, there's a huge discrepancy between how they do the test and the temperature rating in terms of how it's done. I'm Once again, I'm not sure if ASTM, ISO, and any other authorized bodies have recognized it. I would certainly be more than happy to work together with whoever proposed this question to develop something that are more relevant. And it will involve some research and development because there are some lacking information out there. But yes, I'll be more than happy to work on that.
Very good. And no, I think there would be parties, and I think that certain consumer brands in Canada, companies like Canada Goose, have demonstrated that having either internationally recognized standards or defendable testing that demonstrates thermal insulation, that's an effective strategy, whether it's on an individual company basis or among sectors. So it's an interesting question, and I'll forward it to you, and it's certainly something to discuss. Because if you can get a variance between minus 20 and minus 50, that's very clear that we're not properly served by what's available today. Are there actually mannequin-based, installations that cover footwear? Are there some in North America?
Yes, in fact, there are, I know that the Group CTT has a thermal foot, and
Okay.
you can put the footwear in there and then gives you, now, once again, there are different set of standards that they have developed. And the reason why there are differences of minus 30 degrees Celsius between two different labs actually tells you a story. It can be, you may or may not agree with the test method. And one thing that I know, I'm not going to comment on how it's tested and things like that, but one thing that I know is that certain labs put certain test criteria into place that may not correlate directly to the real environment. And in relation to the first question that you raised, I'm actually interested in developing something more closely related to the real environment, because I wore a footwear that had a minus 40 degrees Celsius rating, and I was outside in my car. Temperature was minus 15 degrees Celsius, and within 10 minutes, I started feeling my toes. So, there could be really big discrepancies, and yeah, so it's important for us to try to reflect as many factors that are in our real lives as possible and reflect that into the test method.
Okay. So we have reached the end of our hour. So what I'll do is, first of all, thank HeatMX for the presentation. I'll thank the attendees for their attention and comments. And just to reiterate that the presentation today will be recorded, or has been recorded, and it will be sent to all the people that have registered and or those that, even those that did not attend. So within 24 hours, everyone will get that information. You'll have the links to previous sessions in our series. This is the third and final. And it also will have the contact information you have on your screen here, so that if you have specific questions about HeatMX's products, you will have that email. So once again, thank you to all that have attended. If you have any questions or comments, there'll be ample place for you to do that. And there will be a short survey in your follow-up email, just asking you for some quick feedback. So appreciate that if people would fill that out. So once again, thank you, Say. It was a very good presentation. And after 3 of these sessions, we've had almost 300 people attend. So I do think it does reinforce your basic premise that there's a lot of people that are looking for information on this subject, and maybe we'll be able to help you communicate that to the industry going forward. Okay.
I'd like to thank Bob for organizing all these 3 webinars, and once again, big thanks to your effort, Bob.
Very good. Thanks a lot. Have a good afternoon or evening or morning, wherever people are. Thanks a lot.
Thank you. Bye.
Bye.